Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we'll be looking at a branch of statistics known as scatter diagrams. After this lesson, you will know what a scatter diagram is and how we can use them to represent information. You will also understand the different types of relationships that we can have between the two variables on a scatter diagram. And finally, you will know how to predict future values of a variable by drawing something called the line of best fit onto a scatter diagram and understand where scatter diagrams can be used in real life situations. So, let's get started.
Ooh la la!
So let's have a look at scattergraphs, also known as scatter diagrams. So scatter diagrams are used to investigate a relationship between two variables. And just like in this fashion here, similar to an XY diagram, we would have one variable across the horizontal axis and a second variable up and down the vertical axis. And the diagram consists of many points on the graph that relates these two variables, giving us valuable information, just like this here. So we have points that's scattered all along the graph, hence why it's called a scatter diagram. And each of these points are measured to give a relationship between the variable 1 and variable 2. So this is an example of a scatter diagram collected from the BBC Bitesize website, and it consists of data collected from a classroom of 20 children. When we refer to data, that just means information that we've collected and can process, and each one of these points represents one piece of the data that we've collected. In other words, it consists of data collected from 20 children, and here we have 20 points, with each point representing the data for one child. And in the case of this scatter diagram, the variables we have is height on the x-axis and weight on the y-axis. And we can use a scatter diagram to relate the height and the weight of all the children within the classroom. So let's say, for example, I am this child right here in the class. That would mean that my height would be somewhere in between 146 and 148 centimetres, and it looks closer to the 148, so I'm just going to say my height is around 147.5, and then that would mean that my weight would be equal to something in between 44 and 48, and again it looks closer to 48 than it does 44, so I'm just going to guess this point would be 47 kilograms. And it's in this fashion how each of these other points are collected. So for every student, they would have their height and their weight measured, and that would mean that they would represent a point on this scatter diagram. Another example on this graph would be this point right here, where we have a student that has a height of 138 centimetres and would have a weight of approximately 33 kilograms, which we can see here. So let's say now we want to add a new point to this diagram, or we just want to add the data for a new student. And for this student, their height is 149 centimetres and their weight is 48 kilograms. Well, all we would have to do is find the point that we have the height is 149 centimetres, which is in between 148 and 150 right here. We would then draw this up, and the point would lie where the weight would be equal to 48 kg, and we can see that would be roughly this point right here. So that would then mean that we could add this student's data point to this scattered diagram, and then that would now mean that instead of being a representation of 20 students, this would have 21 students representing their height and their weight. So we can use scatter diagrams to display the information that we have collected for several data points, in this case the data for 20 children measuring their height and their weight. But as I mentioned, one of the more useful things about scatter diagrams is that we can use that to draw a relationship between the weight and the height. For example, we can see in this diagram that as the pupil's height increases, the weight also increases. So we can see here, as we move further to this side of the diagram, then the values for the weight also increase as we go along. And that means that if we increase one variable, the other variable also increases. And when we have this type of relation in a scatter diagram, we can call this a positive correlation. So, as we said, as the pupil's height increases, the weight increases, or in other words, as one variable increases, then the other also increases. But on the other hand, if we have a graph or a scatter diagram that looks something like this, then we can say that the two variables that make up the scatter diagram have a negative correlation, and that would mean that as one variable increases, the other decreases. So we can see here in this example, as we move further to this side or as this variable would increase, then this one is decreasing, just like we can see in this downward slope here. And this here would be an example of a scatter diagram with a negative correlation. So let's say, for example, we collected data across 14 road vehicles, and our variables were the distance driven by the vehicle and the amount of petrol that's in the car. So let's imagine that we've just filled a car up with petrol, and we would have the highest point available that the car could have for petrol. But we know that once the car's been full up, if we drive and we drive more, if we increase the distance that the car's been driven after it's been filled up with petrol, then the amount of petrol is going to decrease. So that would mean that as the distance driven increases, then the amount of petrol that's left in the car decreases. So that means that between these two variables, they have a negative correlation. So going back to the positive correlation example between the height and weight of children, if we have a clear and obvious relationship between both variables, then we can draw something known as the best fitting line, or the line of best fit, in order to make predictions between these two variables. So again, we can use a line of best fit to show the relationship between two variables on a scatter diagram, and we can then use the best fitted line to make estimations on future results. So how do we draw this best fitted line on a scatter diagram? Well, there are many mathematical ways and calculations that we can do to get the exact value of a best fitted line, but for us in National 4, all we're expected to do is to position the line somewhere that suits the general trend. So what I would always look for is to make sure that it follows roughly the same gradient as the points, and we want the line to have roughly the same number of points above the line and below. So I would say something like that there, in between the lines, is a good example of a best fitted line, because we can see we roughly have the same amount of points above the line as below. So therefore we can use this best fitted line to represent the general pattern between the height variable and the weight variable. So here we have this line can represent the relationship between the two variables, and now we have the line in place, we can then use the line to make estimations on future results. So let's say we have a student and we only know their height, we don't know the weight for whatever reason. Then we can use this best fitted line to have an estimation of what their weight would be in accordance to this best fitted line and the data that we've collected. So if the height of the student is 140 centimetres, what we can do is go onto this diagram and go up to the 140 mark on the best fitted line. And then what we can do is represent this on the other variable to get an estimation of what their weight would be. So on this line here, if we draw that over to the y-axis, or the weight variable, we can see that their weight is approximately roughly below 40 kilograms. So we could say that their weight could be approximately equal to 39 kilograms. But let's say this time we have a student and we know their weight, but we don't know the height. Well, again, we can use the best fitted line to estimate what the height of the child would be. So if the weight is 52, then we can go up to 52 on the weight scale, we meet the best fitted line, and then we can go down to the height scale, and we can see that approximately the child will be roughly around 149 centimetres tall. And again, these answers are not going to be exact, but it can give us a good representation or a rough guide to what these numbers might be. Because as we can see here, with all these points that we've gathered, they don't all exactly lie on the straight line, so that means that the answers aren't going to be perfect, but it can give us a good idea to what these might be. And in order, if we wanted to make the scatter graph or the best fitted line more accurate, what we could just essentially do is collect more points, and the more points that we have, then the better the best fitted line will be fitted to these points. So for example, if we only had 5 points instead of 20, then the 5-point one is going to be less accurate because there's less points representing of what the real values are. But let's say we had 100 points instead of 20, then the graph of 100 is going to be more accurate, or the line of best fit is going to be more accurate than the one with just 20 points. So again, just to summarise that, the line of best fit only gives us an estimation between what one variable might be in relation to the other. But nevertheless, it is a very useful tool, because scatter diagrams and line of best fits are the fundamental principles behind artificial intelligence, also known as AI, and machine learning algorithms. So for example, the recommendations that we get in Netflix or YouTube are all driven by the principles behind scatter diagrams and the line of best fit. So they are really practical in real world applications. So when we're asked to make future estimations, We could either do it like that method there that we just did, by drawing line from one variable down to another, but we can also make estimations using an equation of the straight line, just like we did in our lesson of straight lines, where we used the general equation y is equal to mx plus c to draw a relationship between x and y. But this time, when we're dealing with scatter diagrams, we can use the equation of a straight line to draw a relationship between the two variables that we're working with. So let's say that we've been told that the equation of a line of best fit for a set of data is w is equal to 1.5h minus 170, where w represents the weight and h represents the height of the student. And we might be asked to use this equation to estimate the weight of a pupil. In this case, the pupil's name is Sam, who is 150 centimeters tall. So here we have our equation, and here we've been given a piece of information that we can enter into the equation. And this piece of information represents the height of a pupil, so that would mean that h would be equal to 150. And if we want to estimate the weight, we can write out the equation with the value that we have to substitute in. So we would have w is equal to 1.5 multiplied by h, which is 150, and take away 170. So that is the equation of a line of best fit. So what we have to do is we have to multiply first 1.5 by 150, and that would give us 225 minus the 170. And then finally the estimation of the weight would just be 225 minus 170, which would give us 55. So that would mean that the weight, or the estimation of the weight, would be equal to 55 kg. And we can also use the exact same equation to find the other variable if we know the other one as well. So let's say, for example, we've been asked to estimate the height of a pupil named Jessica who weighs 44 kg. So that would then mean that the information that we have is w for the weight, and we know that is equal to 44. So what we then have to do is put this 44 in place of w and calculate h in this equation, because we've been asked to figure out the height. So we can say that 44 in replacement of w is equal to 1.5h minus 170. So I'm just going to rearrange this. So what's on the right hand side of the equation is just now on the left, and vice versa. So now what we want to do is rearrange so that the variable h is by itself. So what we have to do that is take this minus 170 first over to the other side, and because it's minus on this side, it becomes plus on this side. So we have the 1.5h is equal to 44 plus 170, and we know that 44 plus 170 is equal to 214. So that would mean then that 1.5h is equal to 214. So now what we want is h by itself, so we have to take this 1.5 over to the other side, and because it's multiplying on this side, it's going to be divided when we move it over. So we would then have h is equal to 214 divided by 1.5, and that gives us an approximate height of 143 centimeters to the nearest whole number. So that just shows that if we are given the equation of the line of best fit, then we can also estimate the other variable if we've been given one other one. So you might be given it in this equation form, or like we did it before, when we have the graph and you have to draw the line across down to one variable and vice versa. So let's go over a quick recap on this lesson on scatter diagrams. So we said that scatter diagrams are used to investigate a relationship between two variables, such as we have here. We have variable 1 on the x-axis and variable 2 on the y-axis, and they consist of many points on the graph that relate these two variables, giving us valuable information. So each of these points represents a corresponding relationship between variable 1 and variable 2, and each of these data points represents something that's been collected. So this could be a student, for example, or it could be a car, and then the two variables tell us information about whatever this data point is. And we said that if the graph looks like this, where if one variable increases, the other also appears to increase, then this is called a positive correlation between the two variables. But on the other hand, if we increase one variable and the other one decreases, as we can see here with this downward slope, then this is known as a negative correlation between the two variables on a scatter diagram. And if we have a scatter diagram which has a positive or negative correlation, then we can draw in a line of best fit to represent the relationship between the two variables. And we draw this line in by estimation, looking at the points and where they are in the diagram, and 1, making sure that the line follows a general slope or the pathway of the points, and 2, we also want to make sure that roughly we have the same number of points above the line and also below the line. And there are 2 ways that we can roughly use this line to estimate future results. The first way is, if we know the value of one variable, we can draw this up to the best fitted line and then draw a horizontal line across the variable 2, and vice versa. We could draw a line across and then use that to find out an estimation of what variable 1 might be. But the other way is, we might be given the equation of the straight line in the form of y is equal to mx plus c, where y would be this variable 2 and x would be the variable 1, and we can plug in one value of a variable to solve for the other, using the best fitted line to get an estimation on whatever the future result could be. And I also mentioned that the more points we have, then it's more likely that the best fitted line that we have will be accurate, but the less points that we have, then it's likely that the best fitted line will be less accurate. So I hope this statistics video on scatter diagrams has been helpful to you, and if that's been the case, make sure and give the video a thumbs up. And if you have any questions on this topic, be sure to comment down below and I'll get back to you as soon as possible. And if you'd like to see more content like this, make sure you subscribe to the channel, and you can check out our website at penguin-learning.com. Thanks again for watching this video, and I'll see you in the next lesson.